Chapter 10. The introduction of the improved Japanese plums, Satsuma and Burbank, related in the last chapter, was not the result of a plant breeding experiment, strictly speaking. It was more the result of a college course which I gave those Japanese seedlings, taking advantage of the improvement they themselves showed as the result of the new climate and the rest I have mentioned, and after that a training towards my standards for them, which they took on eagerly and easily, and which made of them far better, far different, and far more valuable fruit trees than when they entered my school. Meantime, I had been accumulating more plum stocks and experimenting extensively with them. The 10 left from my Japanese importation proved valuable as a basis for my work. By selection for qualities that seemed to me desirable, I got plums that were better than anything that had gone before them. After that, I went at the work in blossom time and began cross-breeding. If the reader is sufficiently interested to read the next few paragraphs, he will open for himself, perhaps for the first time, a door to one of the most absorbing studies in all nature. If he is not, he can safely skip to later pages. But I promise him that this little excursion into botany will repay him with a greater appreciation of plant life, a new curiosity about flowers that grow everywhere about him, and a higher respect for and understanding of the marvelous workings of nature. I won't be looking over his shoulder, so he can skip and say he didn't, with perfect impunity. If you have not studied the subject, do you not wonder how plants perfect the egg that is within the seed and make it the storehouse for the life that is to come in a succeeding generation? Well, that is what I want to tell you about. For convenience, we call the process breeding, and in many ways, it is amazingly like the same process in animals. But the plant is fixed in one place. Its reproducing organs are the hair-like or wire-like filaments that are to be found in the heart of every blossom, and largely their breeding must be accomplished with the assistance of outsiders. In later papers, I propose to mention some of the miraculous and incredible means nature has for bringing about this essential result in her scheme of things. Now I'm going to explain, briefly and simply, the fundamentals of the process. Every blossom has a number of pollen-bearing filaments that we call stamens, and one we call the pistil. In the anther, at the end of each stamen, are produced the pollen grains, each containing a fertilizing sperm, or male life germ. At the base of the pistil, on the other hand, in the ovulary, rest the ovules, or eggs. The pollen grains, often so minute that it takes a fine microscope to see them, burst from the anthers in due time, and by chance, by action of wind or insect, or by way of the bills of birds, some of them are transferred to the sticky stigma on the end of the pistil. From that stigma, the sperms work through a thin tissue and start throwing out a tube for themselves that eventually finds its way into the ovule, and there the sperms unite with the female life germ awaiting them in this egg, and fertilization is complete, and the beginning of a seed is accomplished. Fertilization is the whole process of uniting the sperm with the egg. In nature, the process may be completed in one individual flower, or the pollen may be carried from the anthers of one flower to the stigma of another. Bees have a strange habit of sticking pretty closely to one variety, so that they are perhaps the most useful members of insect society in crossing flowers in the same family, which accounts largely for diversified colors in the poppies, for example. But other insects are not so particular, and they will go from a honeysuckle to a pansy, from a rose to a fruit blossom, incidentally doing a lot of work that is lost because they carry pollen where it isn't wanted and can't accomplish results. When man takes a hand, he does what he is about, or he thinks that he does, and he employs cross fertilization, or, better, cross pollination, removing the pollen cells from the anther of one flower and carefully placing them on the stigma of another, perhaps of the same variety, perhaps of a different variety, and even, as I have often done, of a different species. The insects do some cross pollination, but it is at random, and only when the heredities of the two plants thus crossed run nearly enough parallel does the cross pollination bring about actual fertilization, and from it growable seed. There are many exceptions to the general rules I've mentioned, and an almost infinite number of possibilities and factors I have not touched on here. For instance, I have not entered on any discussion of the number of flowers, as for instance the rose, that are completely or almost completely sterile and lack either the pistil or the stamens. They have lost the necessity to bear seed because they have been raised from cuttings or by some such subnatural method for so long, and therefore they have lost the necessary seed making and seed fertilizing machinery. I could go on through a number of volumes on this theme, but I should certainly lose all my audience then. So let me hurry along and pick up the folks who left the train back there when we began our botany class and proceed with the plum story. As I said above, the time came when I was ready to begin my attack on the fixed natures of the plums through working with their blossoms, and I took my forceps and glass pollen trays and went into the grounds when the air was heavy with the rich odors and the trees flaming with the beauty of their spring flowers. I began to cross-pollinate. I do not know anything in the work of the plant developer that offers him more pleasure and satisfaction than this process. Fellow to the bee, the hummingbird, the ant, and the butterfly, he goes from blossom to blossom, not attracted, as they are, by the flamboyant colors with which the trees advertise their wares, but by the rich possibilities inherent in the work, guided not by fragrances as they are, but by his own records of the characteristics of the fruit, noted the previous year. In my pocket I carry a packet of sheets, on which are noted the working name of the individual fruit, its size, shape, bearing quality, flavor, color, size of pit, texture of flesh, and so on. On each tree, I have a marker that identifies the individual and refers me to its record. Like a painter choosing the colors for his palette, I choose the qualities that I desire to combine in the fruit. Here, the record shows, is a thin, spindling, unpromising tree that bears a firm, luscious, beautiful plum, beyond a sturdy and well-formed tree that gives a sour, unlovely, or small fruit. The pollen from the one goes on to the sensitive, sticky stigma of the pistil of the other, after this second one has been thoroughly cleaned of its own pollen. Next, I come to a plum of gorgeous dress that has no aroma or flavor. I know a tree that bears a rich and juicy plum that is a drab and unattractive. The two are united in this field marriage ceremony of mine. This seedling offered me, last fall, a firm, well-textured fruit that would be admirable for very late harvesting if I could only make it ripen late. That one yonder is late, but has no other particularly valuable quality. A nice problem here very often because the earlier fruit blossoms earlier. The late ones sometimes almost too late for my marriage to be made possible. What do I do then? Well, I find one of the last blossoms possible to the early tree. I hurry to the late one, and, to my delight, I find one ambitious little bud rubbing its eyes and waking up to see what sort of a world it is coming into. The poky late blossom and the ambitious little early one are my field, and some people think that plant breeding must be tedious and drab sort of work. The crossing is finished. Spring passes. The fruit begins to form. Sun, wind, air, and earth do their appointed work, and the fruit slowly takes on color and final form. I watch as eagerly as a child going every morning to see whether or not the cocoon has found and put in a box filled with leaves has been opened by the butterfly. Is the tree going to bear well? Are the fruits well distributed on the limbs? Does the green fruit hang well, resisting wind and the shaking of the tree? What resistance does it offer pests and disease? These are only a few of the questions I must ask, and that the fruit must answer favorably, or it is doomed. Then the day comes when the first few fruits are ripe. There's a big minute for the plant developer as well as for the man. Perhaps he has something that will add to the wealth of the orchards of the world, something that will present to mankind a new flavor, aroma, color of flesh, quality, succulence, and delicious taste. Or perhaps a step has been made toward one or all of these desirable ends. The first fruit is picked. It is tasted. What is the verdict? But this is not all. As I have said once before in these papers, the mere appearance, taste, texture, sweetness, smell, and flavor of the fruit do not form a complete criterion of its value. Will it ripen without falling from the tree untimely? Will it pick well? Will it keep? Will it cook up? Will it make good jelly? And even if it cooks well in the kitchen, will it satisfy canners? Or, to put it more fairly, has it special characteristics that make it a possible canning fruit? Because in fruit that big, canners will take. The growers of the world have a steady and strong and usually dependable market. On the other hand, if it is not for canners, is it a shipping fruit or one primarily desirable for the home garden or orchard? Test after test, trial after trial, experiment after experiment, acceptance, approval, partial satisfaction, a question, rejection. The fruit stands or falls according to its ability to measure up, not to one standard or two, but to a dozen, 50, 100. And it must not be assumed that all this is accomplished in 1 year or two. I have worked for 12 years now on a nectarine that I am hoping this year will prove itself worthy of release to the growers of home orchards. I suppose that nectarine has cost me $6,000 in time and in actual expenses. If I get $6,000 out of it, I will be luckier than I have been with many of my varieties and new creations. As I have said before, we plant inventors cannot patent a new plum, though the man who makes an automobile horn, not far different from the ram's horn with which Joshua blew down Jericho, can get a patent and retire to Southern California and wear silk underclothes the rest of his life. In speaking of the costs of my experiments, I must refer to the enormous number of plants, branches, grafts, and trees that prove utterly valueless, or of a value that seems doubtful to me, considering the high standards I set, and that must be destroyed. My method of speeding up nature's processes costs me hard work and untiring study and thought, the wholesaling of my experiments. The second half of my method costs me hard cash. Because nature requires compensation in all life, what one gains in time or field for experiment in the plant world, he must pay for in some other coin. I put my mind to cross-pollination and plan the work with infinite patience, care, and research, where the insects and birds and animals are used while they were about their own business, and their efforts are undirected, random, and wasteful. Secondly, I want the largest possible number of variations to choose from, and nature's laws make it possible for me to get them. But the penalty I pay is the expense of growing the tens of thousands that do not measure up, in order to have the material from which to select the 20 or 5 or 1 plant or tree that is what I want, or, more likely, leans that way a little farther than its brothers. Well, from perhaps 25,000 separate and distinct experiments with plums, I got at least 30 or 40 that had merit, and about a score that were a real gift to man. Of those, a dozen are now to be found widely used in the orchards and home gardens of this country and some foreign countries. A few have not yet come into their own, and one or two may never be generally enough approved to be well known. This is because tastes and demands differ wildly. I do not hesitate to say that every single one of my approved plums is meritorious and a valuable addition to the list of accepted varieties, but I am much in the position of a silk manufacturer who, from thousands of designs offered him, chooses 20 to manufacture into dress goods. He may be a man of taste, discernment, and experience, but it is morally certain that he will be outguessed in certain directions by the women and the dressmakers, and that one or two of the designers he got out at so much expense, good though they may be by any proper standard of taste or judgment, will be left on his hands at the end of the season, or bought sparingly and finally marked down with a red tag and sold for what they will bring in. I have never had the experience of having to hold a remnant sale myself, or to cut prices to get trade, but I have a few of my creations that are still unrecognized, and perhaps always will be. I smile at this thought, for I am like a mother with 10 children. 9 of them may become bank presidents and college professors and noted surgeons, or marry such, but something in human nature will make her prefer the runt of the brood, and she will die believing that he was, after all, the prize child, and just somehow missed having the chance the others did, or the luck. I'm that way. Probably all of us are. Once a new variety is ready for distribution, I am confronted with the necessity of making all this work and planning, and this final achievement of practical use to myself and the world, and there are 3 methods by which this is done. I have referred to the plan of filling an order, as in the Impson P. Not long ago, I delivered a very important order to a silk grower in Japan. It was a mulberry tree that, with about the same growing conditions and fertilization as the older varieties, would produce nearly twice as much foliage for the feeding of silkworms. When I had completed the long and complex experiments that ended in success, I forwarded the grafts to Japan, and thus the order was filled.